Welcome, everybody. I'm glad you made it this morning, this early. So thanks for joining my presentation called Does Your Modeling Department Suck? No, it's a catchy title, and if you read the details of it, you know that this is about quality checks, like automatic assessment of how good your models actually are when they come from modeling. And the goal for this presentation is it's going to be a live demo, and I'm going to run you through our setup, like our model check SOP. Basically, I have an example from one of our assets, which turned out that it sucked before, right when it needed to go into texturing. So what we have at Rise is, of course, everybody has like a turntable template where you just feed in every model that modeling spits out, and then you render the turntable for your modeling supervisor or for whoever to take a look at in review. But the thing is, if you look at just the render, you might say, that's a cool model, I like it, let's push it to texturing. But we're currently working on a full CG animation movie, and we have run about like 1,000 assets to model texture, and it turned out that like at 75% of the time, the models get kicked back to modeling from texturing because the texture guys found like the common issues. I'm gonna show you the common issues right now, so that would be. So most of the time you have overlapping UVs, even though the other program that really sucks, I'm not gonna say names, it has a feature that it tells you in the texture editor if you have overlapping UVs and stuff, but still artists might not look at it or might just, they might just not see it. It's not even on purpose most of the time. But yeah, so all those issues, they always pop up when texture guys want to start texturing, and it's like you always lose at least half a day if and every time they kick it back to modeling. So at one point I was like, guys, we cannot continue working like that. We need to find a way to make sure that in our modeling turntable we get the information if the asset is done properly. So I built the SOP that checks for overlapping UVs, flipped UVs, if an object might not have UVs at all, so if stuff comes out of SIGGRAPH, most of the time it didn't have UVs. So then there's something called the UV ratio. It's like if you have two different UV shells that have like the same size in world space, but if they differ in size in UV space, that's called the UV ratio. It's like if one UV shell covers more space in the UV space than the other shell. So that's what we take care of. Sometimes you want that, and it's not actually a bug, but it's just for checking. Then, of course, we do not want UV shells to cross over UDIMs or over UDIM borders. So that's another check we do. Then, of course, sometimes people just put a UV shell like in negative space. That's UDIMs don't work there. So that's another check we do. And then there's just a little quality thing that sometimes faces turn out to have like less coverage in texture space than 1 pixel. So that might be an issue, but it must not be necessarily. So then there's another check for zero length normals that sometimes the other program, for some reason, exports just parts of your objects with no normals. That's okay in Houdini as long as you do not unpack. If you unpack, that becomes a problem. And because we are we have another thing to do automatic texture bakes, like what you would do in Mari, but in Mantra. So with the templates from the Mari extension pack, we recreated them in Houdini, and we bake. And every time you bake with zero length normals, you run into trouble. And next thing that's not in here But we are extending the model check now to check for self-intersections, because if you do a lot of fx, you don't want self-intersections, and you can check that with the new Boolean like quick. So, but it's not in there yet. So, so as you can see, that's what the supervisor sees. You can you take a look at the model, of course, but then on the bottom of the screen, it shows your supervisor what's wrong with the model. So if it says nothing down there, you can approve it. If it says anything, like whatever, it needs to go back to modeling. So as long as there's something on the lower line, it cannot go to texturing. So. So that's for your supervisor. That's the beauty with just the information. So now your artists might ask, so where exactly do I have overlapping UVs, or where are my flipped UVs? And the rendering, that's just the RGB channel of the render. But in the turntable EXR, we have a couple of additional output variables, AOVs, that actually visualize where your issues are. So basically, on the upper right, you see in the red channel, it's flipped UVs. In the green channel, it's overlapping UVs. And in the blue channel, it's shells that are crossing udin boundaries or have invalid udin numbers, like what I just said, the negative UVs. On the lower left, you see on the green channel, or actually it's the orange, it says, no, red is texture area 0, so those faces do not cover texture space at all. Then you have the orange ones is like texture area less than 1 pixel for that face. And the blue ones are the zero length normals, so you might want to check your model. And on the right, you can see the UV ratio. It means all the red parts, they cover much more UV space than the green parts. And the black is actually like the median. It's like black is the average UV ratio for all of those faces, and red and green is just a deviation from that ratio. And the blue ones are actually objects that do not have UVs. So all the vertices have UVs sitting at 0. So yeah, let's go hands-on. So can you read this? It's all good? Cool. So here you see the model. So it's just an alembic that I brought in. And let's see if we can get this side by side so you can... So here comes the model. First of all, we of course unpack because we can't work on packed alembics. Then we have on the asset, on the SOP or on the HDA itself, we have a little menu. So if you are in the viewport, you can choose what you want to see in the viewport. Like everything here gets written into AOVs, but that's just for your viewport to choose for. And of course, there are sometimes you have geometry coming from modeling that is not supposed to be textured at all. Maybe it's like stand-in geometry for hair, and so we put a little exclude group, so you could basically say, so please do not check stuff that has the name placeholder geo in it or whatever you name it. So and also there was a feature that skipped the overlap check for objects with more than 1 million polygons, but it's disabled. We found a way to make this reasonably fast. So yeah, so here we split out the exclude geo, and here already we do the first check for objects that do not have UVs. So that's just a really easy check. I'm just checking if the UV on X and Y is at 0. If that's true, I'll set a new attribute on the geometry called no UVs, and I set it to 1. after that, come here. Oh, middle mouse button is not working anymore. No, it's also that I can still click. Bear with me. No, middle mouse is not working. I'm going to restart Houdini real quick. So, any questions so far?
Does the modeler that built this know you're making an example of it?
Come again?
Does the modeler that built that know that you've shown this?
I think he does not know, but I'm not gonna drop names, so it's gonna be all right. So Houdini. So who of you guys has something similar in place in production? Where do you work? DD, cool. Yeah. So you might give me a few more checks, a list of your checks, maybe. That would be interesting. Come here. So middle mouse is working again. Yes. Thanks. So yeah. So we promote the attribute and then like the no UVs attribute and split that off again. So we only check for for all the other errors, just on the objects that do not have UVs. So let's start with the easy parts. That's gonna pop that out. So that's basically check 1, check 2, 3, 4, 5, 6, 7. It's pretty. You see, it's not that many nodes. It's most of the time I'm using wrangles and attribute promote nodes. So here in this branch we check for overlapping or crossing udin borders or invalid udins. So what you do is like you just convert the UV to a udin, and that's just pretty easy. Just I won't explain it. That's the formula. You find it everywhere, and you're smart people. You come up with this yourself. So so we go from UV to udin. So then we promote that again, and here come again. It's manual. Okay, thanks. So as soon as we have the udin for like for each vertex, I promote that to the actual primitives. So I can check if on a prim, if I attribute promote with minimum, I might get like udin 1001, and in case of an overlap, if I promote the maximum right next to that, and I might get 1002. And if I then compare the two inputs, and if you see if the left input does not match the right input udin, we do have an overlap, and if not, we don't. So and of course I also check if the udin is below 1001, then the udin becomes invalid for your texturing program. So that's the first check. So it's easy. After that, to visualize that stuff, I just blast away all the. Let me check. Yeah. So basically, these are the overlapping the parts that have overlapping udins, and here are the parts that have invalid udins, and here's the rest that's still fine. Then that's just for the viewport. I color that stuff. Like all the good stuff is now, what is it? Black. And in this little Python sub, I just because I run over like the actual object, not the face anymore. We're running over. That's why I packed it. And so whenever that's a bit more. Let's see. So I'm checking, first I bring in all the geometry from all the 3 inputs. Then I create a little list for the overlapping paths. So I'm actually working on the path variable here. So every object that comes from the other program might have, or it has a path variable attached to it, so you can identify the separate objects. So I just have 2 lists. I populate those lists with the objects that are in the overlapping or in the invalid udin group, and then I just give them a color. If I see that the path is in the overlapping paths, it's going to be colored. What's the color? I guess pink. And it gets another variable set called udin overlap. That's what we use later. And we do the same with the invalid udins. So after this guy, you see, if I turn a wireframe, yeah, you see the pink and the blue. And then I just, those guys, they are important for the camera overlay. I'm going to show you that real quick, because I have lots of those outputs. These are attribute promotes. So I just promote the actual error code from primitive to detail. So whenever a single primitive has the error, it will get promoted to the detail attribute, and that's where you can check if you have that kind of error anywhere in your model. So I just use it in a, let me just jump up. I should have locked the, so there's the camera overlay. Yeah, let's pop that out. Help me. Where am I? Wait a second. So yeah, that's basically the font has multiple if statements, and those statements they are looking up those promoted detail variables from the model check SOP. So they say, if you find that the detail attribute error udin invalid is true, then please print then print the udins are below 1001, meaning invalid. Or if you find that a detail attribute error udin overlap is true, then please then print this. So you're gonna end up with this little overlay here. So that's the text, and it goes on with like all the other attributes that you will see later. So that's kind of easy, I hope. So back to the model check. I think I need to hurry. I think we're doing the checking for UV overlaps now, because that's a bit more sophisticated, because it actually uses ray tracing, because I was too stupid to figure out another way. Jeff Wagner always says, there is not one way to do stuff in Houdini. There are like 1,000. It's always depending on the artist, and you have so many tools, and everybody's wired differently in their brains. So that's the way I did it. So if you come up with a faster approach, let me know, please. But it's still reasonably fast. So the IFD creation, even for large models on the farm, is like around about 30 to 40 seconds, and you can just create if the check. If it cooked once, it will not cook on the timeline again. It's basically just 40 seconds, and then however much frames you're going to render, it's not going to take longer than it's not evaluated per frame. So cool. If we want to check for UV overlaps, first of all, what we need to do is we need to bring your objects or your vertices from world space to UV space. So how do you do that? First of all, you need to do something called vertex split. This node gives you like a unique point whenever it encounters a change in the attribute that you can tell it over here. So whenever the UV on like vertices, so you have one point that may consist of 3 vertices, and if this point is part of like 3 different UV shells, you will have different UVs on the vertices, and you need to split that point to bring it into to world space. So vertex split. Then we create the udin attribute again. That's redundant. That's not optimized here, and then we promote that. So we had udin already, and this is actually the point where we move all the points or all the vertices from world space to UV space, and in this space we do the actual ray trace lookup. So I know there's in the UV editor there's a feature that highlights overlapping UVs, and that's basically real time, and it's like super fucking fast. But I haven't figured out how to do that in SOPs at the same speed. But still, you might think I'm stupid if you, I don't know, have a faster way. But basically, what I just do is laying out all the faces in UV space, and I just do a ray trace. Afterwards, it is going in here. So the reason why we we need the udin again is because in version 1 we didn't have that, but it turned out that you don't want to ray trace every single point of your model against every other point. So I just we are constrained to the actual udin that the point or the object is on at the moment when you do the check. So so that's just the for each running over the piece attribute udin. So for every udin we do the ray tracing. It's just a call to the intersect function, the intersect vex function. So here I have initialized a few parameters that the intersect call needs. It's like a few tolerances and the ray bias. They need to be pretty low. And then I actually do look forward and backward. So you might have seen that. Oh no. You might have seen that all the pieces have a slight come here. Anyway, so they have a very slight offset, and that's why I need to trace like in 2 directions and look if I hit any other primitive. So let's see if we do. So the return that you get from the intersect is actually the number of faces that were hit, and I add like the faces I hit looking forward, looking backward, and if I find no, it's not even an if. I just promote that. The number of you will always get, for some reason, you will get always get 1 intersection at all times, and if you have more than 1, you actually had an intersection with something different. So maybe I need to refactor that. But so whenever you have intersections, the error code, error overlapping UVs gets set, and also the color. So if I go here, you can already see that the green, where's the green? Don't ask me why, but okay. Yeah. So for better visualization, we do after that we do a promotion of the actual. It's basically an erosion of the area where you had errors, because if you have just a single or like two vertices that are like turned into green, and you look at it in the viewport or in the render, you might not see it. So that's why we eroded the area a little bit and colored it pink, so you have a little bit more visual guidance in the turntable. So you see, there's something pink, and if you see pink, you have to look a little closer to see if you find a green vertex, and that's the actual overlap. So because in version 1 we didn't have that, but then we found out that there are some cases where it's actually hard to see where the actual overlapping UV was. So we introduced this little erosion thingy. So what you do is you just promote the color from point to primitive. So basically, all the primitives around the point that has the overlap will get the color as well, and then you just promote that back to points, because you want to have the CD on the point, and so yeah, that's just a erosion more or less. Just promote up, promote down, so it's basically eroded. So, and that's actually where the green comes in. That's so if I find the attribute, or if there's overlapping UVs on a vertex, I set the color to 3, and if not, then it stays the eroded color, which was the pink. So you can see here. So the pink is not an issue, but it's a visual guidance. Maybe I can find you, for example, here. Just imagine this piece to be way smaller, and you would not easily see this little green thingy here. So there's like, if you see pink, look for the green. Okie doke. Then that's where it goes to the text overlay again. So that's where you can check for the detail attribute called error overlapping UV. And I think that's already it for the overlap checks. What else do we have? Do we still have time? Do we want to do a Q&A, or so? Sorry, basically ran out of time. Do you have questions? Yeah, go.
Yeah. So I was wondering, since your modelers are doing UVs and you're detecting errors, would you consider moving your modelers into Houdini so that they can see the errors while they work?
We thought about putting this into like it's in HDA already. Oh. We might use Engine in the other program, but there's just some. To be honest, it's not licensing issues. But if we use Engine in Maya, we might like grab a few licenses that are then not available at the farm, which is kind of a problem. We don't have dedicated Engine licenses just for the artists. That's the reason why we did not yet put it into like the Houdini Engine thingy. But I think that's the better way to go. We need to just find a way to, if we are inside the other program and the modeler wants to check stuff, he just brings in the HDA like for a short time, and if he's done, he need to figure out a way to automatically get rid of the HDA and not use or block a license anymore. Yeah. That's maybe something we need to talk to side effects to make this more feasible. I don't know, or maybe we need to do something. We just need to buy more licenses, I guess. Yeah. So yeah, thanks for the question. Anyone else? So yeah. No, then We have 2 more minutes. The UV ratio, that's fine. So if you want to measure UV ratio, you just go. So first of all, I calculate the median, like who does not know? No, it's just something like an average, but a different formula. So here I find out about the average UV ratio for all the objects. Forget about that switch, we're not using it anymore. And after that, I just, we have measured before, let's see. I did measure stuff. Did I? Ah, yeah, texture area. Yeah, so to be able to compute the UV ratio, you have to, of course, measure the area that your face covers in world space, and then compare it to the area that your face covers in UV space. So I'm doing two measures, and then I just in here I compute. Oh boy, yeah. I think we're done. Yeah, okay, it's 10. Thank you very much, everybody. Thank you.